One might ask, and it is a question I have encountered many times, posed with perfect sincerity by people of considerable intelligence, one might ask, where did the Big Bang happen? Where in space is the point from which the universe expanded? If one could travel far enough, fast enough, in the right direction, could one arrive at that point, the place where it all began, the center, the origin, the spot in the cosmos from which everything we see, everything we know, everything we are, was once expelled in a single cataclysmic instant? The question is natural. It is in its way beautiful. And it is wrong. Not wrong in the sense of being imprecise or incomplete, though it is both of those things. Wrong in a deeper sense. Wrong in a way that reveals something profound about the limits of human intuition, about the distance between the world as we experience it and the world as it is, about the strange and sometimes terrible gap between the language we have inherited and the reality that language is called upon to describe. The Big Bang did not happen at a point. It did not happen at a place. It happened, and here one must speak carefully because the ordinary meanings of words begin to fail. It happened everywhere. It happened here, where you are now, and there, wherever there may be, and in every location in the observable universe simultaneously. There is no center. There is no edge. There is no place from which the expansion proceeds, because the expansion is not an expansion into something. It is an expansion of something, of space itself, of the fabric of the universe, of the very medium in which the concept of place has meaning. These things, as one discovers, forced us to reconsider the relations between science and common sense. They forced on us the recognition that the fact that we were in the habit of talking a certain language and using certain concepts did not necessarily imply that there was anything in the real world to correspond to these. I learned this first at Göttingen under Max Born, when quantum mechanics was young and we were young with it, when Heisenberg and Dirac and Pauli and Born himself were dismantling the comfortable certainties of classical physics and replacing them with something stranger, something more beautiful, something that offended every intuition we possessed about how the world ought to behave. But the lesson applies with equal force to cosmology, to the question of the origin of the universe, to the Big Bang, a name, I should note, that was coined not by its proponents, but by Fred Hoyle, who meant it as a term of derision, who preferred his own steady state theory, and thought the idea of a singular beginning was faintly absurd. The name stuck. The derision did not. Let me be precise about what we know and about how we know it, because precision matters. It is, in matters of this magnitude, a form of moral seriousness. In 1929, Edwin Hubble, working at the Mount Wilson Observatory with a 100-inch Hooker telescope, then the largest in the world, published observations demonstrating that the galaxies beyond our own are receding from us, and that the velocity of their recession is proportional to their distance. A galaxy twice as far away is moving away twice as fast. This relationship, Hubble's law as it came to be known, though the Belgian priest and physicist Georges Lemaitre had derived it independently from Einstein's field equations 2 years earlier, in 1927, and had been largely ignored for his trouble. This relationship is the observational foundation of modern cosmology. The constant of proportionality, the Hubble constant, has been measured with increasing precision over the decades. Its current best estimate is approximately 67 to 73 kilometers per second per megaparsec, depending on the method of measurement. And the discrepancy between these values, the so-called Hubble tension, is itself one of the most intriguing unsolved problems in contemporary physics. But the basic fact is not in dispute. The galaxies are moving apart. The universe is expanding. Now the natural, the almost irresistible image that this conjures is one of an explosion. A bomb goes off at some central point, and the fragments fly outward in all directions, and the farther fragments move faster. And if you could run the film backward, you would see everything converging to a single point, a single instant, a single place. This is the image that most people carry in their minds when they think of the Big Bang. And it is, I must say with as much gentleness as clarity permits, fundamentally misleading. The galaxies are not moving through space away from a central point. Space itself is expanding, carrying the galaxies with it. This distinction, which sounds, I recognize, like a philosopher's quibble, like the kind of thing one might argue about at a seminar at the Institute after too much coffee and not enough sleep. This distinction is, in fact, the single most important thing to understand about the expansion of the universe. And it is the thing that almost everyone gets wrong. Einstein understood this. He understood it before Hubble's observations, because his general theory of relativity, published in 1915, the most beautiful physical theory I have ever encountered, a theory that any man whose errors take 10 years to correct is quite a man for having created. His theory predicted it. The field equations of general relativity describe the relationship between the geometry of space-time and the distribution of matter and energy within it. And what the equations show, what Alexander Friedmann, a Russian mathematician, first demonstrated in 1922, and what Lemaitre independently confirmed in 1927, is that a universe filled uniformly with matter cannot be static. It must either expand or contract. Einstein, who was uncomfortable with this implication, famously introduced a cosmological constant, a term in his equations designed to hold the universe still, and later called it the greatest blunder of his career. Whether it was a blunder or not, and the recent discovery that the expansion of the universe is accelerating, driven by what we now call dark energy, has given the cosmological constant a rather dramatic second life. The point is that the equations, from the very beginning, told us that the universe is dynamic. It is not a stage on which events take place. It is itself an event that has been unfolding for approximately 13.8 billion years, and that shows no sign of ending. But what does it mean to say that space itself is expanding? And how does this differ from an explosion in which objects move through space? Consider, if you will, a thought experiment that I find useful, though like all analogies it has its limits and should not be pressed too far. Imagine a balloon, a very large balloon if you like, though the size is not the point. And imagine that tiny dots have been painted on its surface. As the balloon is inflated, the dots move apart from one another. An ant sitting on any one dot would observe that all the other dots are receding, and that the more distant dots are receding faster. The ant might conclude, reasonably from its limited perspective, that it is at the center of an expansion. But an ant on any other dot would reach exactly the same conclusion. Every dot appears to be at the center. No dot is actually at the center. The expansion is a property of the surface itself, of the space in which the dots are embedded, not a motion of the dots through that space. This analogy captures something essential, but it also introduces a temptation that must be resisted. One is tempted to ask, what is the balloon expanding into? What is the space outside the surface? And the answer, the difficult, counterintuitive, but necessary answer, is that there is no outside. The surface of the balloon in this analogy is all there is. There is no three-dimensional space surrounding it into which it expands. The expansion is intrinsic, a stretching of the fabric of the surface itself. And this is precisely what general relativity tells us about the universe. The universe is not expanding into anything. There is no pre-existing void, no empty stage, no container. Space itself, the three-dimensional space in which we live and move and have our being, is the thing that is expanding. And to ask what it is expanding into is to ask a question that the theory, and perhaps the universe, does not permit. I have spent many years at Princeton in the company of some of the finest mathematical minds of the century, Einstein among them, though by the time I arrived at the Institute, he was pursuing his unified field theory with a devotion that the rest of us admired but did not share. And I have learned that the difficulty people have with these ideas is not a difficulty of mathematics. The mathematics is clear. Friedmann's equations, the Robertson-Walker metric, the Friedmann-Lemaitre-Robertson-Walker solution to Einstein's field equations, these are not ambiguous. They describe a universe that is homogeneous and isotropic on the largest scales, the same in every direction, the same at every point. A universe with no center, no edge, no preferred location. The difficulty is not mathematical. It is imaginative. It is the difficulty of forcing the human mind, a mind evolved to navigate a small, flat, three-dimensional environment on the surface of an unremarkable planet, to comprehend a reality that is curved, expanding, possibly infinite, and certainly nothing like the world our senses were designed to perceive. And here one arrives at something I think is quite simple and quite deep. The question, where did the Big Bang happen, assumes that the universe is a container, a box, a room, a space, and that the Big Bang was an event that occurred at a particular location within that container. But general relativity tells us that the universe is not a container. It is the container. Space is not the stage on which the drama is performed. Space is part of the drama. It was created, or rather, it emerged, it began to unfold in the Big Bang itself. Before the Big Bang, and here the words begin to fail most completely, because before implies a time prior to the origin of time, which is a concept that may be not merely unknown, but unknowable. Before the Big Bang, there was no space for the bang to happen in. The bang created the space. The bang created the time. The bang created the conditions under which questions like where and when became meaningful. There is a passage in the Rig Veda, one of the oldest texts in any language, composed perhaps 3,000 years before the birth of Christ, that I have thought about in connection with these matters more than once. It is the Nasadiya Sukta, the hymn of creation, and it asks, who really knows? Who will here proclaim it? Whence was it produced? Whence is this creation? The gods came afterwards with the creation of this universe. Who then knows whence it has arisen? The hymn does not answer its own question. It holds the question open, suspended, vibrating, unresolved, in a way that I find deeply consonant with the situation in which modern cosmology finds itself. We know a great deal about the first fractions of a second after the Big Bang. We know that at approximately 10 to the negative 36th seconds, 1/trillionth of a trillionth of a trillionth of a second, the universe underwent a period of exponential expansion called inflation, proposed by Alan Guth in 1981, which increased its size by a factor of at least 10 to the 26th in a time interval so short that light could not have traversed even a single proton diameter. We know that by 1 second after the bang, the temperature had fallen to approximately 10 billion degrees, 10 to the 10th Kelvin, and that protons and neutrons were beginning to combine into the lightest atomic nuclei, deuterium and helium-3 and helium-4, in a process called Big Bang nucleosynthesis. We know that the abundances of these light elements, approximately 75% hydrogen and 25% helium by mass, with trace amounts of deuterium and lithium, match the predictions of nucleosynthesis theory with remarkable precision, providing one of the strongest pieces of evidence that the Big Bang model is correct. We know that at approximately 380,000 years after the bang, the universe had cooled to roughly 3,000 Kelvin, cool enough for electrons to combine with nuclei to form neutral atoms in a process we call recombination. and that the photons released at this moment, freed from the dense fog of charged particles that had scattered them incessantly, have been traveling through the universe ever since, cooling with the expansion, and are now detectable as the cosmic microwave background radiation, a faint glow of microwaves with a temperature of 2.725 Kelvin, uniform to 1 part in 100,000 in every direction, filling all of space. Arno Penzias and Robert Wilson discovered this radiation in 1965 using a horn antenna at Bell Labs in New Jersey. And their discovery, which they initially attributed to pigeon droppings in the antenna, an explanation that, while lacking in cosmic grandeur, was at least testable, their discovery confirmed the Big Bang model in a way that no other observation had. And the cosmic microwave background tells us something extraordinary about the Big Bang, something that bears directly on the question with which we began. The radiation is uniform. It is the same temperature, to extraordinary precision, in every direction we look. This means that the universe, at the time the radiation was emitted, was essentially the same everywhere. The same temperature, the same density, the same composition. There is no hot spot, no bright center, no remnant of a localized explosion. The uniformity is the evidence. The Big Bang happened everywhere, simultaneously, filling all of space with energy and matter, and the space itself has been expanding ever since. But one might stop here and feel that the picture is complete. It is not, because the uniformity of the cosmic microwave background, while it confirms the Big Bang, also presents a profound puzzle, one that troubled cosmologists for decades, and that led eventually to the theory of inflation that I mentioned a moment ago. The puzzle is this: regions of the sky that are separated by more than about 2 degrees, which corresponds at the time of recombination to distances far greater than light could have traveled since the Big Bang. These regions have the same temperature. But how? If these regions were never in causal contact, if no signal, no energy, no information could have passed between them, how did they reach the same temperature? It is as if you opened 2 rooms on opposite sides of the Earth and found them at exactly the same temperature, despite the fact that neither room had ever been connected to the other by any channel through which heat could flow. Inflation solves this by proposing that the regions were in fact in causal contact in the very earliest moments, before inflation, and that the exponential expansion then stretched them apart so rapidly that they are now separated by distances far greater than the observable universe. The uniformity is not a coincidence. It is a memory, a trace of an earlier, smaller, hotter state in which the universe was small enough for all of its parts to communicate, to equilibrate, to reach a common temperature. And then inflation stretched this uniformity across the cosmos, painting the sky with a smoothness that we can still detect 13.8 billion years later as the cosmic microwave background. I have been wrong about many things in my life. I was wrong, I have said this before, and I say it again because it remains true, and because the repetition of uncomfortable truths is a discipline I try to practice. I was wrong to believe that the clarity of scientific understanding could be straightforwardly translated into the clarity of political or moral action. The universe yields its secrets with a kind of reluctant grace that I find beautiful. Human affairs yield nothing with grace, reluctant or otherwise. But I do not think I am wrong about this, that the question, where did the Big Bang happen, is, in its way, one of the most important questions that a human being can ask. Not because of the answer, which is strange and difficult and unsatisfying to the part of us that wants a place, a center, a fixed point, but because of what the answer teaches us about the nature of our understanding and its limits. The universe has no center. This is not a deficiency of our knowledge. It is a feature of reality. There is no privileged position, no special place, no location that is more fundamental or more important than any other. The Copernican principle, the idea that we do not occupy a special place in the cosmos, which began as a hypothesis about the Earth's position relative to the Sun, extends in modern cosmology to the deepest possible level. Not only are we not at the center of the solar system, not at the center of the galaxy, not at the center of the observable universe, there is no center. The concept itself does not apply. And this, I think, is either humbling or terrifying, depending on one's temperament. And perhaps it is both. John Donne wrote, in a poem that I read many times during those dark months at Cambridge, when I was young and miserable, and had not yet found the consolation that physics would eventually provide. Donne wrote of the new philosophy, by which he meant the science of Copernicus and Galileo, that it calls all in doubt. The element of fire is quite put out. The sun is lost, and the earth, and no man's wit can well direct him where to look for it. Donne was writing in the early 17th century, and the loss he described, the loss of a cosmos with a center, with a fixed and comprehensible structure, with humanity at its heart, was already acute. How much more acute is it now, when we understand that not only is the earth not at the center, not only is the sun not at the center, but there is no center at all, when the very concept of a cosmic center has been dissolved by the mathematics of general relativity and the observations of modern cosmology. There are children playing in the streets who could solve some of my top problems in physics because they have modes of sensory perception that I lost long ago. And I think sometimes that those children who have never heard of the Robertson-Walker metric or Friedmann's equations, who do not know what a megaparsec is or why the Hubble constant matters, I think those children might understand, in some intuitive way that we have been educated out of, what it means to live in a universe with no center, because they have not yet learned to place themselves at the center of their own experience. They have not yet acquired the habit of treating their own perspective as privileged. They live in a world that is to them vast and undifferentiated and full of surprise, a world in which every direction is equally interesting and every place is equally strange. And this, if the cosmologists are right, and I believe they are, this is closer to the truth about the universe than the adult conviction that we know where we stand. One is led to think, and I say this with a hesitation appropriate to a man who has been wrong often enough to be suspicious of his own convictions, that the deepest discoveries of cosmology are not, in the end, about the cosmos at all. They are about us. They are about the limits of the human mind, the inadequacy of human language, the persistent and perhaps ineradicable tendency to project our own experience onto the universe and to mistake the projection for the reality. We ask, where did the Big Bang happen? Because we cannot help it. Because we are spatial creatures, creatures of place, creatures who navigate the world by knowing where we are in relation to things. And the universe answers, everywhere and nowhere. And the question does not apply. The Vedas speak of Brahman, the ultimate reality, the ground of all being, as being without qualities, without location, without form, permeating all things and identical with all things. I do not claim that modern cosmology confirms Vedic philosophy. The relationship between physics and metaphysics is subtler and more perilous than that, and I have seen too many facile equations between scientific discoveries and spiritual teachings to trust them easily. But I will say this, that the cosmological picture of a universe with no center, no edge, no outside, no privileged location, a universe that is in some deep sense the same everywhere, resonates with certain very old intuitions about the nature of reality that the Western scientific tradition, with its emphasis on measurement and localization and the identification of causes, has sometimes been slow to accommodate. I said once that science is not everything, but science is very beautiful. The Big Bang is beautiful, not in the way that a sunset is beautiful, or a painting, or a line of poetry, though it partakes of all of these, but in the way that a truth is beautiful, a truth that does not flatter us, that does not confirm our expectations, that does not grant us the comfortable illusion of a center, or a beginning, or a place from which to survey the whole. It is beautiful because it is honest. It tells us what we are, not the center of the universe, but a part of it, a small, temporary, astonishingly improbable part, living on a small planet, orbiting an ordinary star in an ordinary galaxy, in a universe that has no center, that began everywhere at once, and that continues to expand, carrying us with it, whether we understand it or not, whether we accept it or not, into a future that no equation we possess can fully predict. Both the man of science and the man of action live always at the edge of mystery, surrounded by it. And the mystery of the Big Bang, the mystery of an origin that is not a place, a beginning that is not a point, a creation that creates the very space and time in which creation can be spoken of. This mystery does not diminish as our knowledge grows. It deepens. It becomes more precise, more detailed, more richly textured, and at the same time more strange, more resistant to the comforting frameworks that the human mind instinctively reaches for. The equations tell us what happened. They do not tell us why. And whether the why is a meaningful question, whether the universe owes us an answer, or whether the question itself is a projection of a need that the universe does not share, this, I confess, I do not know. I know only that the question exists, that it is ours, and that to hold it open, without flinching, without premature resolution, without retreating into easy answers or comfortable myths, is, I think, the highest form of honesty that a thinking being can achieve. The universe began everywhere. It began here. It began where you are. And the light from that beginning, cooled to microwaves, stretched by 13.8 billion years of expansion, uniform to 1 part in 100,000, still fills every cubic centimeter of the space around you. A whisper from the origin, a memory of a time when everything was together, not because it was gathered into a single point, but because the universe itself was smaller, and there was nowhere else for anything to be. We are, all of us, standing in the place where the Big Bang happened. We have always been, and the knowledge that there is no other place, no center to seek, no origin to visit, no fixed point from which the cosmos unfolds, this knowledge is either a loss or a liberation, and I suspect, as with most things that matter, it is both.